Hello, this is Coenter Heidi, and this is the beginning of the Framework Command 1 beta tester program. In this beginning video, I'm going to introduce you to the FC-1 programming language. I'm going to be using build 0.0.3 build R, and it's the latest at this time. Likely by the time this video is released, a newer version will be released, but the code will remain the same. So, I'm going to be presenting a few different ways of writing the hello world statement using FC-1, as there are a few options for you. And I'm also going to be briefing the structure of FC-1. So, first of all, we're going to need to create a new file. Just make a text document and rename it to active.fc1. Active is the name the interpreter looks for as the main beginning file to launch from. Active, the .fc1 register is what FC-1 also looks for in scripts. There's a few other registers that exist also in FC-1. There is a name.thread.fc1. Thread.fc1 is a subregister that's used for thread scripts, and yeah, that's the other one. We'll cover thread.fc1 in a later video, but active.fc1 is the main, and the name active also comes into play. When we change scripts, we can name it whatever we want, but the first one is active. This is the launcher file. It's fc1.exe. You won't find any information inside of it. That's because it was designed to just be distributed. It's designed to be distributed, so you can attach your own licenses to it. Anyway, so if we open this, let me make it bigger than you can see. We have nothing in it from this by default, so let's go over the structure. There's a few operators we need to get out of the way from the bat, straight off the bat. FC-1 is not a simple programming language. I'm going to get that out of the way first. There's a lot of elements to it, and it will be confusing. It takes a lot of lines, and it's very low level, so you have to be very careful when using it. I have implemented as many fail-safes as I can find into it. However, there is still dangerous areas in it, especially when working with memory. In FC-1, all memory is low-level memory, so you have to be really careful when using it. But if you figure out how to properly use FC-1, it'll be a very, very fast language. So first of all, structures. There are indexes, there are libraries, and there are commands. These are each represented with a symbol. The index is the star, the library is a plus, and the commands are underscores. So all other things you have to remember are everything that is opened must be closed. So in the case of, for example, I'll name a library. This is an index. This is star I. I must be closed at the end of the sequence. We have the in-between, and so I can have a command in here with its, this is a library, and this is a command inside of it. However, I has to be closed, and a library occasionally will also have to be closed using a command called return, spelled as return. There are a few other things. So along with this, this, and this, there is also this. This is a comment. And then we have this. This is a breakpoint. It's used in debugging. So yeah. The libraries are named by, or indexes are named by calling an index and then putting one of the labels next to it. Labels are always a single operator. There is a, there's I, and they're always a letter. So for example, I is the input label, and it controls input and output functions in FC-1. There's also V that controls variable functions, M for math, T for threading, A for access, X for external, and things like O for operation, and F for function. So right in this script that we'll be writing right off the bat, we're going to be using two of them. We're going to use input output, and we're going to be using R. R is reserve. Reserve streams are things you won't call very often, so they're lower down in the priority. In FC-1, every command that you run has a cycle, and these cycles will control how fast they are run. The R itself is a low priority index. I is also a fairly low priority index because it's more of a graphic. However, the library A, that's called access, will normally be used for handling functions that you would run in I, and is a high priority index. But we're going to use I because it is a much more basic library index. So we have these two libraries inputted. I is going to go before R, and at the end of I, we're going to close it by saying I, and then closing the index. So, and we don't have to do that for R, because R is going to be how we're going to close the program. The program will close automatically and cleanly if I just run I and close it like this. That is completely fine. The issue with this is we won't be able to see our results because a console window will open and then immediately close. So what we're going to do is we're going to use the reserve stream, keep it open so that we can see what happened. So what are we going to write in here? Well, we're going to need a command library to run. So I'm going to use the library output, and I'm inside of this index, and I'm going to use output. There are no objects inside of FC-1, so everything is it starts at line 1 and it's going to end at the bottom line unless specified. You can tell it to do other things. So output is here, and then I'm going to need to specify hello world in output. I cannot just write hello world here. That's not going to work. There are also no quotation operators inside of FC-1. It doesn't use those. It's very line by line based. So I'm going to use the command line. So I'm going to output on a new line. This next line, line 4, is my target. It is a target. It's the target line that I'm going to be covering. So I'm going to say, in this line, I'm going to say hello world. I can't use this script here because output is open-ended, an open-ended library, which means you have to close the library using an internal command. So now that I've called line, I can't say another thing here. It's taken me back to where a new index where I could call line again if I wanted to. So I could say line and hello world, hello earth. And this would also work. We have to close output so that we can close input. So I'm going to remove this, and I'm just going to say ret. And this is return, the return statement. So now that I've returned, I cannot just leave the program there. This is considered an unclean program. And what it's going to do is all of the memory that you've loaded into RAM by calling hello world here is going to stay in RAM once you close the program. And that's going to cause an unclean program. So what we do is we close input, and then the program knows it'll how to end safely. But if I run this now, this code right here, I'm going to save it and then run FC-1. It'll close instantly. It's fine. It ended correctly, so we're in safe terms. But we want to see what we outputted. So I'm going to go to reserve stream. I'm just going to say terminate. And now I get to set the terms of the program closing. And I'm going to tell it I want it to key out my program. And this is all I have to write. I don't have to return this. I don't have to return this, and I don't have to close the reserve stream, because everything ends in this library has no exit. It is an open-ended without a closing. So if I run this, we're going to see this. Hello world, press any key to continue. And that's the beginning. What if we want more information? We want to know a little bit more about our program. Maybe we did something wrong and we want to find it. What you can do is you can say debug at the end. And it's going to output all of this information. Have I encountered a deprecated command or library? Was there an error? What was my last process? What was the last line I was on? What did the error look like? And if I purposely put an error in here, like for example right here, I could say after this, oops, and I could run that. And it reached debug, so we have all that. It ended on line 10, but it tells us the error that we got. It'll put a absolute value bracket next to it, and then we'll get the error here, and it'll tell us that there's been an error to help us identify it. Normally, however, I just use key out. There is another one, there's clean, which does the same thing as if you were to just not have this code in the first place, but it is optional if you want it there. But there's also an unclean. The unclean operator doesn't unload any commands you put into RAM. There are reasons why you would use this. But it's very unsafe and puts any memory you've loaded at risk. So if you were building a password manager, per se, all your passwords would stay in RAM if they were loaded there. So it can be quite a dangerous tool. But anyways, this is one way. I'm gonna leave the reserve stream there. Key out. And I'm going to I'll get rid of this, and I'm gonna show off another way of hello world, saying hello world, and that's by using the group command. I can say group hello world, and then I can say ret again. If I was to just leave it the way it is now, I'd get a syntax error. Group allows me to output on multiple lines. So hello world, goodbye world. If I was to take this sequence here and run it, I would get this. It's all been condensed to one line. We don't really like that. So what we're going to do is we're going to just say underscore break in between here. And this is a command group recognizes. So I run that, hello world, goodbye world. But you notice there's still this outside. So there's an option. I can have the ret here, the return here, and I can put a break after goodbye world. But another thing I can do is in the same layer that I called group in the first place after this ret, I can call break. And it will separate. Other things I can do is if I could call two of them, breaks like this, and it would push this back another line and leave an empty space here. But there's one more way of doing a hello world, and it's a little more complex, and it's using memory, using the string operator. So there are a few operators in FC-1 that you need to know about. There's the integer, the double, the float, the integer 64, the boolean, and the string. These are the main operators that act the way you expect them to. There are a few others that exist, however. There's the flux, the chart, the quantum, and yeah, that's currently in FC-1. These are the variables that exist. Potentially, there is one other, and it is the error level. However, this is not really a recognized variable. And anyways, so these are all data type that you can use inside here, and we're just going to use the string data type for our next hello world statement. So closing all of this, we need to do a few things to get string set up. It's not as simple as calling string and storing something in it. So we need to enter the variable index. And we're going to start by forming a library, calling a library. So normally in a programming language, you can just store it right away. However, in FC-1, you have to allocate memory ahead of time. So I'm going to allocate, so I call the allocate library, and I'm going to specify the type. And I want it to be a string, and now I get to input a number here. Or, alternatively, I can reference an integer, but I'm going to, in this case, use a number, and I'm going to say, I'm going to allocate one string. And now, we're in a little more dangerous territory when it comes to memory, because we've allocated this, but now we have to return and leave the allocate library. There is a fail-safe in if we don't return, the program will crash, and it will remove all the memory that's been loaded. So there is a fail-safe in allocate and the variable library. It's a fairly secure and well-built library. The index itself also has fail-safes built into it, because we do not want memory lingering in the in RAM. There's a reason the terminate unclean command exists, and it's because if you want to leave memory there, we will let you use our method of leaving it there, rather than causing us an error. We want there to not be errors when the program closes. So anyways, we've done all this, and we've allocated it string 1 return. So next, we need to store. So I'm going to say store, and I'm going to specify the type, and I'm going to say string. And now I get to do it. I cannot specify an int inside of a string. I can, however, there is another variable stream that is called convert, and it will be used for converting strings, integers to strings to integers, the likes. But we're not going to do that here. So in here, I'm going to say hello world, and strings can only hold one line. So that's this line. Next, I'm going to have to exit the library. Alternatively, if I want, another thing. There's an offset between the allocate and the string. If I allocate one string, I also have to specify the string as 0. The string I've allocated is string 0. There are no names in FC-1. Every variable type has a number attached to it. In this case, the number is 0. It's not 2, it's not 3, it's not 1, it's 0. If I allocated 3 strings, the numbers would go from 0 to 2. See if I can do this. There we go. To 2. If I have 10 strings, it's going to go to 9. So if I have 1, there is, I'm calling string 0 and I'm putting hello world in it. Next, I have to return to leave the storage facility. If I wanted to, I could also say store another string in the same instance of the library, but I'm not going to. Anyways, we're done in the variable stream, so we're going to close it. Next, we're going to hop over to the input stream, and we're going to call output again. This time, however, we're going to use var, and we're going to specify the type. Var is another command that goes in the index that's in the library along with line and group and break. So we're going to use var. So I'm going to say the type, and I'm going to do string, and I'm going to say I want to output string 0. And I don't have to put a ret after here. It's automatically going to put me into the same index var we called var from. So it's going to put me back into the output library automatically. If I wanted to call another variable, I'd have to say underscore var, then name the type again. So now that I've called this, I'm going to call a breakpoint, and I'm going to, so that we don't have key out on the same line, and I'm going to return and leave the input library. Next, I'm going to close it. Then I'm going to say r plus terminate underscore key out. And we're done. So if I run this, hello world, key out. So we've got 22 lines, and that's admittedly, it takes a little while. FC-1 is not it's a very, very efficient language, but it'll take some time to code in. So now you know that's how we work FC-1. That's going to be all for this video. You can play around with it more. I'm going to try to release documentation for the commands. If you want to know a few other things, if I remove this and I say int, say this is an int, I can put this and it will be completely fine. It just won't put a value in int. And I'm going to say 42 is the int I want to store, and I'm going to then say this is 40 is an int. And if I run this, I'm going to get 42. There's also bool, and there is yeah, you can mess around with the variables. It should be noted that double is a 64-bit float. Float is a 32-bit double. Int 64 is the 64-bit variant of the integer, and string by default is not really defined. So yeah, that concludes. Bool obviously is still true and false. Should be noted actually if we allocate a bool though. It's a little you can mess around with bool the way you like, but there's a few different things you can specify in here. I can say 0, false, 1, true, underscore true, underscore false. I can just say true or false also. Another thing, I can put a random in, and that's false. It's only looking for true statements. That's how a bool works, and it's how we make it efficient. So bool, and now if I run this, it's 1. because it's true. And thus concludes this video. Next time, I'm going to go a little more in depth into variable stream, and we're going to show off mathematics, and I may even show off if statements. So they're going to be using the assignment point library index, and it's not really a library or an index. It's just they're points you can call, and yeah. So yeah, this concludes this video. Thanks for watching, and enjoy the rest of the beta program.